We're moving on to Chapter 8. The first section is 8.1, Meaning of Area. And I'm sure you've been familiarized with area in previous math classes, but we're going to go ahead and review that again, just to refresh it in your mind, and then we'll go more in depth as it applies to our study of geometry. So the first thing to remember is that area describes how much space is included within a two-dimensional region. So in this case, we have a bunch of squares, and the squares show us, they demonstrate for us how we talk about area. We always talk about area in terms of square units. So you've probably heard someone say that the area of the wall that they're going to paint was 100 square feet, or that the area of a certain room was 200 square feet, and that's what they're talking about. So as you can see, we have these units of squares here. So this is 1 square unit, this is 2 square units, 3 square units, and we could keep counting and see how many square units this shape is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. And so we would say that this rectangle is 28 square units. Now those units can be feet, inches, millimeters, yards, miles, any light years. It can be any unit of length, but we say it is square units because we are taking the area and multiples of these square units. So let's see how that relates geometrically. So let's define the area of a region. It is the number of square units needed to cover that region completely. And so this is the same rectangle that we had in the previous slide. So the square units needed to cover this area is 28 square units. Oops, sorry, let me go back there. 28 square units. Now just a note, that can be written 28 square units, or it can be written as 28 units squared. Okay, that means the same thing. And so we're going to look at how to find the area of squares and the area of rectangles in this section, but you can also use this to find the area of other shapes as well. Even though triangles are not squares or rectangles, we can use them by figuring out how many whole squares here, and then how many partial squares are in that triangle. So that would be 1, 2, 3 whole squares plus 3 halves. That would be 4.5 square units for this triangle. And we can do that with any shape. We can figure out how many square units fit inside a shape. Let's go ahead and look at some of the first postulate that applies to this. Postulate 8.1. Sorry. Postulate 8.1 is the area postulate. Every region has an area given by a unique positive real number. And so like I showed in the previous slide, we could make any region, any shape, and it would have area. As long as it is a region, it has area. You can make any two-dimensional figure there, and it would have area. Now notice that area is always positive. You can't have negative area. You can take away area, in which case we would express it as a negative, but you can't actually have negative area. So the area of any region is going to be a positive number. Postulate 8.2 is the congruent regions postulate. This says that congruent regions have the same area, and that makes sense along with everything else that you've learned about congruence, right? Congruent line segments have the same length. Congruent triangles have the same angle measures. They also have the same side lengths. And so congruent regions have the same area. Postulate 8.3 is the area of square postulate. This states that the area of a square is the square of the length of one side. So when we say the square, we mean that we are going to raise the length of the side to the power of 2. Okay, so that's what it means when it says square. So the area of a square is the square of the length of one side. So let me go ahead and draw a square in here as best I can. I'm sketching it, I'm not drawing it, so it's not going to be perfect. But I have a square there, right? And the definition of a square is that it is a quadrilateral with 4 equal side lengths and 4 right angles, and that's what we have there. And so we can count how many square units this square is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 square units. Let's go ahead and use the formula now. Okay, so if we use the formula, we say that the area is equal to the length of one side squared. And because all the sides are the same, it doesn't matter which side we use. And so here we get the length of this side is 3. Of course, they're all going to be 3. So let's stick a 3 in there. 3 squared, and 3 squared is equal to 9. 9 square units. Okay, and so that is how we calculate the area of a square. Now, it's possible to go backwards to start with the area and calculate the side. If we know that a square has 16 units squared as the area, we can go backwards. So we have 16 units squared is equal to the side length squared. To undo a square, we have to do a square root. So we're going to square root both sides. Square root of 16 is equal to the square root of s squared. And a square root undoes a square. So on this side we have s, the length of one side, and the square root of 16 is asking what number times itself is equal to 16. And the answer to that is 4. So that we know if we start with area that is 16 units and we need to find the side length, we can figure out that the side length is 4 units. So it goes both directions. So let's look at this example. Example 1. Find the area of square ABCD. Now once again, we're not given units. We don't know if this is feet or miles or what, so we're just going to use the term units. And so what we would do is we would set up our equation that we just learned. We just learned that the area is equal to the length of one side squared. So area equals side squared. And then we're going to go ahead and plug in what we know about this square. So let's measure the length of one side. Oops, didn't mean to click forward there. Let me get my pen back. Okay, so the length of this side is 1, 2, 3, 4. 4 units, and as you already saw when I accidentally clicked forward, we replace s with 4, so the area is equal to 4 squared, and 4 squared means that we do 4 times 4, so that gives us an area of 16 square units. So make sure you understand how to find the area of a square in this way. Postulate 8.4 is the area addition postulate. If the interiors of two regions do not intersect, then the area of the union is the sum of their areas. I'm going to read that again, and I'm going to point out a few things. If the interiors of two regions do not intersect, then the area of the union is the sum of their areas. What does this mean? So let's pull up our nice grid here again, and I'm going to go ahead and color in. Let's say we have I'm going to get a fatter pen here. Let's say we have this region. Okay, pretend that coloring goes all the way to the edges there. And we have this region here. Okay, so we have two quadrilaterals next to each other, and their interiors do not intersect. Okay, so the parts that are within their boundaries do not intersect each other. Okay, so that's the first part. If the interiors of two regions do not intersect, then the area of the union, right? And union means the two things together. So the area, sorry, go back to my pen. So the area of the union is the sum of their two areas. So we can find the area of the orange section and the area of the purple section, add those together and get the area of the entire region that we have there. Theorem 8.1 says the area of a rectangle is the product of its base times height. So the formula for that is area equals base times height. So if we have our rectangle here, let me go ahead and let's do a kind of a flat long one here. Okay. So we're going to take our base, and really it doesn't matter which way you say this is the base, but base actually does mean bottom. So let's see. The length of the base here is 1, 2, 3, 4, 5, 6 units. Let's put a 6 there. And the height, 1, 2, 2. So the area of this rectangle is the base, which is 6, times the height, which is 2. And so that equals 12 units squared. 12 units squared. And notice this is the same way that we find the area of a square, but because the square, the base and the height are the same, that's why we square it instead of multiplying side times side. In this case, we're doing the same thing, but they're not the same, right? You have a different base and a different height, so you have to multiply the two together. To find the area of a polygonal region that is not convex or that has no special area, you can separate the polygon into portions for which you can find the areas. So what this is saying is when it says that has no special area, that means that there's no special way to find the area. Like with a square, you find the area by multiplying the side times the side, or side squared. For a rectangle, you multiply the base times the height. Even if there's not a special formula, you can still find the area of a polygonal region by separating it into different portions, finding the individual areas and adding them together. This is similar to what we did with the polygons and dividing them into triangles, but now we're going to divide them into squares and rectangles. So let's take a look at that. It says, find the area of the given region. Okay, and so we have all these lengths here of the different sides, but this wouldn't fit to put it into the area formulas that we've been given already, because it's not a square, it's not a rectangle, but it is made up of squares and rectangles. And so we can subdivide this into multiple rectangles and figure out the area. So if we put in these lines, then we end up with 1, one, two, three, 4 different rectangles. We can find the individual areas of those rectangles, add them all together to find the area of this shape. So let's go ahead and do that real quick. So for rectangle A, we know that this section right here is 4 units, and from here to here is also 4 units because it's 4 here. So that is 8, and then we know that rectangle A is too high. So A is equal to 8 times 2, which equals 16 units squared. Okay, now let's do B. B is 8 and 2. So that's the same thing. B is equal to 8 times 2, which is equal to 16 units squared. And C is 4 and 1. I'm going to come over here. C is equal to 4 times 1, which is equal to 4 units squared. And D is, now notice there's a number here, there's 10 and there's 8 up here. 10 refers to this whole length here, but this part is not included in D. And we know from the top that that is 2. That means that this is 8. So 8 and 2. So once again, we have another 8 and 2. D is equal to 8 times 2, which is equal to 16 units squared. Okay, so now we can add up all of those to get the total area of this figure. So we're going to do 16 plus 16 plus 16 plus 4. Okay. And then I'm going to notice that 6 plus 4 is 10, and that 6 plus 6 is 12. And I'm going to add 12 and 10. That's 22. So put a 2, carry a 2. 2, 3, 4, 5, 52, and I was adding all those. 52 units squared is the area of this figure. So notice how we were able to divide it up into sections and to figure out the area by finding the area of each of the pieces and adding them together. So your assignment for this, go ahead and go to Google Classroom and look for 8.1. If you get stuck and don't know how to do it, go ahead and rewatch this video so that you can confidently do your homework.